excited about tonight's talk. We have Windisch here from Docker, as you guys know, or he's a security engineer at Docker, and he's here to tell us a little bit more about the underlying technology and Docker. Before we start, we'll do something that's become a bit of a standard, which is go around the room and just have everybody introduce themselves. Just state your name, title, and anything else you want, and where you work, and anything else you want to mention. I'll start with Pete.
My name is Peter Shannon. I'm an operations engineer at Weber. I'm Jason Cole. I am a front-end engineer at Weber.
Tom Bell, operations engineer at Weber. I'm going to jump right in. Dan Russo, web operations at Weber.
Chris McNaughton. I'm actually a co-founder at Worth It.
Sanjay Modi, IT director over at Ward. Phil director of IT at Vagrant.
Michael Costello, front-end dev at Windisch.
Developer here at
Jeremy Stinson, VP of Network Operations, meeting.
Derek Bond, operations engineer at
Ben Ryan, I'm a senior operations engineer at Italy. Jordan Idle,
Ted O'Connor, I'm the CIO at Wingspan.
Steve Corso, DevOps engineer at Vagrant Technology. I'm Paul Hash, cloud software engineer at Sunway. Jerry Gallagher, I'm a systems administrator at Vagrant.
I'm Mike Smalley. I'm a DevOps/systems administrator here at Meetup. Also want to thank Meetup for sponsoring this meetup. They give us the venue and buy pizza, and that's fantastic. So really appreciative of that. Without further ado, let's get started.
Thank you. Let me know if you can't hear me back there. If not, I'll speak louder or we'll get a mic. I didn't get my turn, so I'm Windisch. I'm at Docker. I guess that was already announced earlier. How many of you, I'm sure you've all heard of Docker a little bit. How many of you have played with Docker? Good, all right, about 50%. So Docker is an open source containers technology. It's also an ecosystem and API for driving containers and managing processes on Linux, and I'll get into that in a little bit. The title of today's talk is Docker for Developers, I believe. So I'm going to try and cover a little bit about how to use Docker, not just what Docker is, which it covers a little bit of, but also some of the best practices. So this slide is half up to date. I stole this from our DockerCon back in June, and I updated the contributors line and crossed the others out because I don't know the current numbers. But we've had exponential growth, so where we had 250 meetups, there's probably 500 meetups or something. And I'm sure we have many more than 300 million downloads. 3 million downloads. But we do have 640 contributors. I know that. And we have the Docker engine and the Docker hub to build, ship, and run. Users, everybody's using Docker these days. Every day it seems that we hear of a new Fortune 100 or Fortune 500, Fortune 100, even Fortune 10 companies using Docker. We have over 60 people employed at Docker Inc. Docker originally, we had pivoted. We were previously a company called .cloud. It was providing a platform as a service akin to a Heroku, and we pivoted to providing Docker and providing that software as an open source component. Docker provides components. Docker Inc. provides components to build, ship, and run your images. Docker itself, the engine, does really all of this itself, but the hub provides cloud-based components, and really that's what Docker Inc. does, is we provide the hub and we provide support and services for Docker. So Docker is trying to solve the problem of, again, running and shipping your applications. I'm going to start from the developer's machine, right? Your Vagrant, where you might already be using Vagrant today if you're not already using Docker. And I find that many users, developers, are effectively given shacks in which to build and test their applications. You know, these little shacks in the water that are barely standing on stilts, right? It can fall over at the smallest wave. And this is basically this one-off role Vagrant environment. It's a specialized environment for dev and testing. Sometimes those environments don't work out well, the ones that say the organization provides, and developers roll their own and they do their own thing. It doesn't look anything like what their production is going to look like. It doesn't look anything like what their testing and CI system is going to look like. For testing and CI, many environments build these big complicated systems that again look nothing like production to run their applications. Nor does it look anything like, say, their Vagrant setup, because they are drastically different, and they're drastically different in order to provide this testing and in order to simulate all the peripheral of ways that the application can be deployed and used by the end user ultimately. But this, right, this is what we're actually deploying. This is our actual production environment. And again, it looks nothing like our CI. It looks nothing like a dev environment. And Docker, through standardizing containers and standardizing the interfaces and the images, provides a sea of sameness, something that everyone can be cookie cutter. All of our containers, all of our environments can, at least in theory, be effectively the same. And it doesn't matter if you're running that image on your laptop, if you're running it in your CI, if you're running it in production. That image should run the same way in each of those environments with a few caveats, perhaps based on your kernel. And that eliminates this variance, right? And it eliminates the "it worked for me" problem. For physical goods, of course, we use the intermodal shipping container. Before this, goods were literally shoved into trucks, and then we decided to start building pallets and putting them into containers. And we have, of course, containers for Linux. I didn't know this is a build out. So if it works locally, it should work on the server with the same behavior, regardless of the underlying distribution, and regardless of the versions of the software and the dependencies. You do have to be running Linux. You need to have kernel 3.8 or higher. There are backports to RHEL 6, so I don't know the exact kernel version of RHEL 6, but that has backports that allow namespaces and Docker containers to work. Officially, we support x86 and 64-bit kernels. Docker itself can work on other architectures, but the images that we build don't have architecture flags. So we promote the idea that everybody should currently be using 64-bit x86 until we can shoehorn architecture awareness into those images. Furthermore, I'll add that Microsoft has agreed to, has announced that they will be introducing Docker support in Windows 10. So currently, Linux, future Windows, how that actually works, I guess is to be decided, but Microsoft is apparently working on that, which is pretty exciting. Containers are lightweight. We can run tens, hundreds, thousands of containers on a machine easily. If you could, basically, if a machine can run a certain number of processes, it can run that many Docker containers. There's really no overhead between a process and a Docker container because a Docker container is effectively a Linux process with certain security constraints put on by the kernel, just as file access constraints are put on by the kernel. In fact, many of the security constraints are already set by the kernel on your processes today, but they're set with the defaults, which are entirely permissive. That, in theory, a end-user application is allowed to elevate to root and modify files in the system without checking directory access controls. There's a system capability for that. That is not masked by default. So in theory, if your process could somehow elevate to root, it could access that capability. Docker wraps around these existing capabilities that are already in Linux and enables them and uses them. So, sorry.
Why don't you update its performance better, Docker?
I didn't make this graph. I think that there was a case where there was a sync issue where technically it was slightly better, but it's the idea is that it's basically the same. The numbers are within a margin of error.
You're talking about the direction of the arrow? Well, the latency one has a performance gain of going Docker versus pure native. So either they configured something in
right.
Docker's relative to the kernel that a native process wouldn't normally be configured.
Right. I think this was I believe a quirk of AUFS that was being used in the test. Since then we have other storage drivers that are a little better than that. The bandwidth one's probably a little bit more realistic. So on the left we have a traditional environment where you have, on the far left, hardware you literally run processes on it, and then you have hardware you can run VMs on it and processes in those VMs, or simply processes and processes directly on the bare metal. Because if you're running, for instance, KVM, you're not just going to be running VMs on that machine. You're going to be running VMs on that machine and the other processes that are part of your operating system. In an ideal Dockerized environment, all you are doing is you're containerizing those processes that you already have. So the processes that are running directly in your hardware, and as well as the processes that are running inside of your VMs, can be containerized. And what this is showing is that VMs and Docker are not in conflict. It's not Docker or VMs. Now there are cases where you may say, I'm using VMs for the wrong reason, and I will only use Docker. And I will replace my VMs with Docker because I'm not using VMs for security constraints, or I don't need VMs with Docker. But you don't need to eliminate VMs to use Docker, and there can be advantages of combining them. I kind of hate this slide because it says lightweight VM. You can see a Docker container as a lightweight VM. It has its own process space, its own network interface. It can run things as root. It can have its own init system. And this is an init system different than the host. But, and also I should call out, it can run multiple processes. But it is generally advised to run one process per container. And the reason for that, I'll get into the next slide. But there are also the ideas of 12-factor and scalability of applications and modularity. But what I'll get into in a moment will cover more of a security angle, which is here's your traditional host. And this host can be a VM, this host can be bare metal. And you have 4 processes. You have a syslogd, an nginx, some sort of backup agent, and an SSHD. You may have any arbitrary number of processes on host, and they may be doing any things. These are just 4 ones I figured that people in the room may be running in one way or another. And these are all running on the metal, or they're running in that same system. And they're running within the same security context. And with Docker, what we do is we effectively put an equivalent of a firewall between these processes. And these processes can no longer share their file systems. They can no longer share the same PID namespace. They no longer share memory. They no longer share any of these things that they might have otherwise shared, or at least many of these things. But then we can also have the ability to poke holes between these processes in these firewalls, just like we can poke holes in a network firewall. And this is something, this is where Docker and VMs are really completely different solutions. Because VMs, yes, you can separate VMs from each other with effectively a firewall between those VMs. But those VMs contain multiple processes. And we can't effectively poke holes in the way that we can between processes. I like to make an analogy more of Docker provides separation of processes in the same way that rooms or cubicles provide separation inside of a building, and VMs provide separation in the way that a fence surrounds a house, right? You may want both. You don't need to have both necessarily, right? But I would advise anybody that if they're going to build a house and put a fence around it, they should also probably have some rooms in that house. So I see that Docker can be used as a security product. It can provide a wraparound processes. It provides a path towards trusted compute in a way that we haven't really had before. There's some really unique opportunities here that we can sign your bootloader, we can sign your kernel, we can sign your initRD, and we can sign the Docker images. And you can be sure that everything that you're running on that machine has been signed. And this is something that Linux has fairly failed at doing up until now. And this is something that we're going to be able to provide with Docker. And of course, you can use VMs to wrap containers, and you can use containers inside of VMs. And in some virtualization technologies, you can even wrap some of the user space tools that run. So for instance, you can wrap QEMU in a container. So you can make sure that if a breakout occurs in a KVM instance that communicates back to a user space QEMU, that QEMU is now semi-contained. It can't be fully contained, but it can be semi-contained so that certain types of attacks can't propagate out of that.
Question?
Sure.
Can you clarify the last bullet point?
That's what I was trying to clarify.
What's the difference between wrapping a container with a VM and containers inside of VMs?
You know, I think that I meant to also say that you can run VMs inside of containers, but you can also somewhat wrap VMs with containers. In that, again, those user space tools, like user space QEMU, can be wrapped. So each of these processes is going to run from an image. This is an example that each of these processes can run from the same image. And it would only run this single process, but the file system that it's based on is coming from this image. And it contains rsyslog, nginx, Amanda for the backups, and OpenSSHD. We can, of course, also run special images for each of these. And you may not be able to read this back in the back, but the first image is based on Ubuntu, the second is based on Fedora, Ubuntu, and Debian. So you can mix and match these file systems, just of course like you can mix and match distributions with VMs. But these are different distributions running on the same machine without virtualization, which are effectively CH roots, to be honest, right, from a certain perspective. But it makes it easy to run these different distributions, and you can get support from these different distributions. And as an app developer that's deploying an application, your users don't have to care that, oh, well, they can only run RHEL 7. Well, the hardware's running RHEL, right? They still get support from Red Hat for the hardware and for running RHEL on their hardware. But they get to now run your application that might be based on Ubuntu without possibly running into some of the concerns that organization might have about running a non-RHEL system. So I'm going to do a little bit of going through some of the things we can do with Docker more practically. So we're going to first start with building an image. And Docker is, at its heart, at least in part, an image builder. And this is actually only using 3 of the commands we have for Docker files. There may be something 20 or 30 different commands you can put in a Docker file. You have from here at the top. We have run, which is literally run shell commands. Here we're exposing a port, 8101, and we're specifying a command. You can also specify commands such as entry point, which is like a command, but it allows you to use the container almost like the arg0. So it specifies an arg0 for the command, and then any command arguments to the container itself are just processed as arguments. We have env for environments. We have add, which can add local files from the file system or from tarballs, etc. But once we have this file, which we call the Docker file, like a make file, we can then build docker build -t, which says we're going to name the resultant image jpetazo couchdb, and dot, which says take this Docker file from the current directory. You can tell Docker to build images from URLs or from Git repositories as well. And of course, any directory. in this case, dot.
Question. Can you contrast that to something like Packer?
Sure. So Packer is somewhat similar in that Packer can build images for multiple systems.
Right.
One major difference is that each of these commands in a Docker file creates an image, and it layers upon each build process. So if, let's say, we have 3 different images that all look have the first 4 lines in common, for instance, they will all have a common ancestry. So if all just these lines are different, you have 5 Docker files and they're all the same for those first few lines and they're just different here, they'll all share an ancestry of those commands that are there. That's one difference. Another is that Docker files, of course, are native to Docker. Docker can run in any of the environments that Packer supports. So you can take, in fact, it would be possible
Packer
with...
builds Docker containers.
It does technically, but they're not native Docker images. But yes, they exist. Another thing is that these images, you can run them through automated build systems. Docker itself can build them, so if you want to have a fully native Docker system, there are a lot of tools that work with Docker images and do Docker builds. A lot of the integration tools, CI systems, and so forth work with Docker files and Docker, and that is a process that works together very well. And again, you could actually build something that looks like Packer, like that provides the functionality of Packer with Docker itself. I find personally that I'd much rather create a Docker file to build a Docker image and then export that and then import that into convert that to an EC2 image or convert that to something then to use Packer. But certainly people are using Packer as well. It's not my preference.
It just seems like there's an overlap. That's why, you know.
Sure.
What tool would you recommend that would take Docker? What tools are there to take Docker files and create EC2 images?
There's probably fewer than there should be. I said there's probably fewer than there should be.
Okay.
I know that it wouldn't be hard to do it. Conceptually, you can build an image and you can do Docker export, and that will create a tarball of a file system that you could convert to an AMI pretty easily. The other thing you could do too.
Packer does work pretty well.
Sure, yeah, and I recognize that. I personally just find it not very useful to me because I have a Docker workflow and. Well, I do work for Docker, but even if I didn't, I would.
Dog food, right?
But even if I didn't work for Docker, I mean, before I worked for Docker, I was using Docker, right? So now, in building images, there's a lot of ways that people kind of build these images and they approach how these images should look and how they're built. I recommend that people build as much into the image as possible at the time of building the image. So you put as much of it into the image build process as opposed to at the runtime process. So for instance, if you're familiar with using Chef, most Chef environments look like, here are my Chef recipes, here are my cookbooks, and I am going to start my server up, it's going to connect to my Chef server, or even use Chef Solo, it's going to pull down these cookbooks, and it's going to converge and run all these scripts, and it's going to configure my host. And now my host is configured. And then I'm going to start using my host, and it's going to change the state of my system, but whatever, right? But we're doing that in the runtime of the system at some point. It's not in the image building process, right? Your image building is some base, in most cases I found at least, it's some base operating system. It's a bare Ubuntu. It's maybe some image that you've built that has some basic utilities, perhaps Chef itself. But it's not configured, right? You have Chef come up and configure it. The idea with Docker images, I say, is to build as much of that in the image building itself, and then do a post configuration, which I'll get to in a moment, right? You don't want to build an image and then deploy a container and then build a bunch of things inside of it. I like to say that this is not making sandwiches, but baking everything into bread and then putting a little bit of peanut butter and jelly on top, right? It's okay to do this, basically put something on at the end. Yes?
Can I ask why? Do you think it's better?
Sure. I actually have a really long presentation that I did DevOps Days Pittsburgh on that, which is on my SlideShare. I do have the next slide, though, gets a little bit more in depth, which was from that presentation. I had about 20 different slides that looked kind of like this, that evolved to this point. So this is actually Chef Container. Actually, this was not Chef Container when I made the slide. A week after Chef came out with Chef Container, which looked like my slide. And Chef Container is actually a project from Chef that follows this model that I'm advocating, where it will use Chef to build the image, and it will use Chef to configure the container. So packages will be installed into your image. Most configuration will be written into the image. Things that are going to be fairly static configuration, right? The static configuration items are built into your image. What happens at runtime, so here's your image, right? So you build an image, it runs Chef, it configures and creates the image. That image is what you use to run. That image is used to create and run a container. This is your actual running process. That process at runtime starts Chef, which reconfigures the container and does basically last-minute configuration options. Now, there are different reasons for doing it this way. Some of them are such as speed. Docker can run containers very, very quick. You can run containers in milliseconds. So for many use cases, people don't want to wait 2 minutes, 10 minutes, 20 minutes for Chef to run and configure and converge their container. They're looking at millisecond launch times. This is something that allows them to do all the heavy lifting load earlier, and then just do a few seconds perhaps of Chef configuration at the last minute to say, we have a new domain name. We have some SSL keys to insert into the image, whatever it might be. So this is the actual model that Chef themselves are now advocating, and it seems to be the direction that many of the configuration management tools are going towards when they're talking about Docker integration. So I hope that answers the question. Yeah, and like I said, there is the DevOps Days Pittsburgh. If anybody wants to hear more about this, there's a recording of that as well as the slideshow. So we're going to then run our container locally, and you'll see that I'm going to provide different Docker run commands for running locally, running in CI and staging, and running in production. The same image is used, but there's a few different reasons why we're going to give different commands to Docker. So we're going to use docker run -t-i, which means allocate a TTY and make the container interactive. Basically saying we want to open effectively a shell to this, right? We want to be able to get std out, std error from this and debug it and see what's going on because we're in dev testing mode. We also want to remove the container. You don't have to do that. This means that when this container stops, we're going to delete the file system. So anything that we wrote to disk, we're going to discard. If you don't put that here and the container stops, anything that was written to disk will persist to your disk. And if you do this 10, 20, 100, 1,000 times, you're going to have a bunch of files on your system and you're going to have to manually clear those out because every container runtime is going to leave logs and things you're going to have to manually clear. If you're doing fast iteration, you might just want to have that delete automatically. And of course, this is the image, for instance, that we built with the Docker file earlier. And then we can do a Docker PS. And Docker PS will show us the containers that are currently running. Now, a container will end as soon as the process ends, because a container is a process, or a process tree. So when that process tree ends, the Docker container will no longer list in Docker PS. So you can do, for instance, docker run busybox space sleep 10, And if you have Docker installed, that'll automatically let you download BusyBox if you don't have it already. We'll run sleep 10 in there, and that container will run for 10 seconds, and then automatically exit. Actually, I'll add that if you didn't run -rm earlier, and you do ps-a, it will show you all these stopped containers. And that's how you can then get and see the containers that you might want to use for listing logs or getting other information out of, seeing their file systems, etc. Pushing to a registry, this is pretty simple. So Docker Inc. provides something called a Docker Hub. There's also private registries. So a registry is an image repository that you've built your image, you've done Docker build, you can now, and you've tested that image by doing Docker run. Now you want to push this into a registry so that other machines, either your machines or other users, perhaps on the internet, will want to download and use these images themselves. So you would then do Docker push user/image. Now, if you're running a private repository instead of user, you provide the address of your registry. And this could be basically an IP address or domain name. Got that? So from there, we would then run that. Presumably, you have a CI or continuous deployment, and you can run this automatically in CI, staging, etc. And there are CI services that either are built on top of or integrate with Docker. If you are running your own CI service internally, as long as you can shell out, you can use Docker. If you are looking at using Docker as part of your CI system to run your app, some of these systems also allow running their slaves inside of Docker containers. But in many cases, that prevents you from actually deploying and using Docker containers natively. So I know that Shippable specifically allows you to run your own Docker containers, which is really awesome. The other ones, I'm not so thrilled about in the sense that you can't natively run Docker containers in a hosted sense, right? So for instance, Travis CI, you cannot just spawn Docker containers, I don't think. Jenkins, of course, if you're running on many of the systems like Jenkins, if you're running it in your own infrastructure, you can shell out and do whatever you want, and you can run Docker. So, presuming that you have a CI system that's just going to take an exit status, you can do something like do a Docker build. So we're going to build our image. That means building the image, but also bundling our application into a Docker image. We're going to take the ID of that so that we can do a Docker run. So we'll do Docker run, and ID is going to be the name of the image that we've built. And then if this completed successfully, of course, our exit status will be 0. And most systems will automatically, do a set -e and exit immediately as soon as something fails. Anybody? I know this is like some shell magic. So anybody have questions about this? Okay. A little sideline. So anybody here heard of Fig? Okay, so we have a couple people. So Fig is a sort of a local orchestration for Docker. And with Fig, you can say, we're going to run, for instance, 2 containers on this machine. We're going to run web, and we're going to run Redis. And web is going to automatically build a Docker image and then run that Docker image. It's going to change the command up a little bit. It's going to specify different port mappings, volumes, and links. The link is saying that it's going to connect the networking between the web and to Redis, so that the web server can access the Redis server. And we're also going to launch a Redis server. And what you would do is, this is a YAML file, and you would pass this to the Fig program, and Fig will launch these containers and configure them as they're configured, and if necessary, build Docker images. This is great, of course, if you're running this on a Docker host on your bare metal, where you can do that. I like to run this in something that I've built, which is called Figleaf. And fig leaf is a Docker container for running Docker containers with Fig, which may sound complicated, but in CI it's really useful because you can say, I want to test my application on my CI server, but I want to actually, my application needs to, we're doing integration tests and we have to have my application talk to Redis. Well, we can actually spin up Redis and build your application, bring up your application, and bring up the dependent Redis server all inside of Docker. And we can do that with one command. And that's what doing this would do, which is Docker run privilege. And privilege says that this is not going to be a contained container. So we're going to use Docker for the build and the ship and the run, but we're not going to use it for any of the firewall capabilities, right? We're going to shut down any firewall, and we're just going to say this is going to be unprivileged because we're going to run Docker inside of it. The containers that Fig is going to launch will be unprivileged containers. So they will have firewalls in there. So we're basically going to kind of remove the outer fence, but then put those effectively those constraints on those processes inside. And -v allows us to provide bind or bind mount file systems into containers, which we're doing here. So we can say when we run a container, we are going to bring in either anonymous volumes, which is a way of saying that a process can run and have a private file system and share that with another container, or bind mount directories from the host and map them into the VFS, the file system of the container that we're launching, which is a great way of being able to preserve the state that runs in your container. Because generally people use Docker for running ephemeral-like processes in a sense that you would run EC2 in an ephemeral state without EBS. So the -v provides an EBS-style solution for the ephemeral nature of Docker. Did I lose anybody there? Probably a lot of people.
EBS?
Can you tell Fig to start a container, like the Redis container first, and make sure that the container is operational before the application starts?
Sorry, what's that?
Can you tell Fig to start the database before the application and make sure the application has a database to go to?
Yes.
Okay.
Yeah. I don't know if Fig can specify a waiter though. So if you want to do that, you might have to. It can wait on those containers to start. So if you had to, let's say, ping the database and make an HTTP request before you start the other container, that might be a hack. I think you can do it, but it would be a hack. It doesn't natively do something to that degree. But it can definitely make sure that the process, has actually been spawned before you start the other container. Your question was, what is EBS? And EBS is Elastic Block Storage. So it's a way of, so EC2, when you spawn a VM in EC2, generally those instances, you spawn them up and you make changes to the file system, and anything you save to the file system disappears when you stop that VM. EBS is a way of attaching block devices that are on a SAN, a storage network, into your VM. And of course, when you save the files to those devices and you stop the container, you can, or stop the VM, you can start a new VM that can still access that block device. It's basically a cloud-based SAN. So the -v provides something akin to that for Docker. All right. And then finally, we will run our container in production. And in this case, what we'll do is we will not remove the container on, and actually I meant to remove -t-i because you're not going to want that in production. You'll probably want -d, which is daemonize. You'll make rm false, which I believe is default, which of course will preserve your state across restarts of the container. And we can actually specify that if this container stops for an unnatural reason, such as we didn't actually issue Docker stop, it will automatically restart itself and retry for 5 times. We can specify that it does not do that, which is no, on failure with the max retry or always. The max retry is kind of useful because otherwise your process can just effectively fork bomb your system if you're not careful. But that was a pretty highly requested feature that we added, I believe, in 1.2, which was last month or 2 months ago. So, but as you can see, every time the same image is used in each case, or we can use the same image, but how we run it might just differ slightly based on how we want to store the data, how we want to do things of that sort, right? Or restart policies, etc. The typical things that change from laptops to production. So, in addition to that, we have managing Docker and orchestrating Docker at scale and doing more of what I would consider hard ops. So creating containers is easy, right? We've seen that we can create containers easily. We can do Docker run, and the container is going to run, and it's going to be the same in all of these environments. But managing them needs improvement, because what happens is that now, instead of having, I don't know, 100 VMs, we now have 1,000 containers, and we have to have a way of managing that and keeping track of those containers and managing the sprawl of those containers. There's an ecosystem of products that are trying to solve this problem, and this is certainly not an inclusive list. I'm sure there are many others. Some of these, Mesos definitely is an OpenStack, and Google is really standing for Kubernetes, which is a pretty popular open source project now that they revealed back in June. CoreOS is not so much of a management ecosystem. It's an operating system that includes some tools that helps you manage your containers, but doesn't natively manage containers for you. It provides, for instance, some cluster management tools that you can use to query what containers you have running in, and so forth. You have Cluster HQ, Clocker, Diaz, and Flint. Every tool is different. I can't advocate or recommend any specific tool. I am the maintainer of the OpenStack drivers, so if you have questions about those, I can answer those directly just because I maintain that code. There's also a PaaS ecosystem. So there's OpenShift, Stackato, Cloud Foundry, and also OpenStack. And these are tools that allow you to build applications in, say, a Heroku style. So you can take your Rails application and shove it into one of these, or your Django application and shove it into one of these PaaS frameworks, and then they will manage building Docker containers for you and running Docker containers for you. And some of these may also integrate with CI systems. So they may already integrate with Jenkins or Shippable or one of these other CI solutions you may already be using. But these are not going to be a Docker native solution, right? These are not solutions where you would build your own Docker containers and run them. These are you build your app, and you have a suite of products that understand your style of app, such as Rails or Django, so forth. Each of these configuration management tools has some sort of Docker integration. So everybody seems to want to work with Docker today. So Chef, Puppet, Salt, Ansible, and even CF Engine have been working on Docker integrations. I really can't recommend, as someone who works at Docker, can't really recommend one over the other. But
Can you recommend any of those over CF Engine?
Although I would say that, well, the guys at Chef really impressed me with releasing Chef Container. Many of the other tools, some of the other tools have recommended that you continue using the same paradigms with Docker that you've used before on your bare metal systems, where Chef said that you should change the paradigm and use Chef Container. CF Engine, surprisingly, while not the newest of tools, has been surprisingly aggressive on their marketing, where I have seen them having a bigger and greater presence at container-related conferences and events than the other players. I'm not sure what they're actually doing, but apparently they still exist. And their marketing is in greater force than ever, it turns out. but not well enough that I know what they're actually doing, so I'm not sure it's effective. So there's container inventory services. So these are services that run independently of some of these orchestration solutions. So if you wanted to kind of build your own ad hoc system, or if you wanted to somehow get your own, manage your own container solution or container inventory, these, I guess, three are ones that I'm aware of. There's SkyDoc, which is DNS based, and Surf, DiscoverD, SDUtil. DiscoverD and SDUtil, I believe, come out of Flynn. Surf, I forget where that comes from, but you can just use these tools independently. They have effectively come out of some of the other orchestration solutions and can be independently used. All right, finally, we have the Docker Remote API. So Docker itself, so these tools I just described, all use in one way, or most of them use in one way or another, the Docker API. In fact, Docker itself uses the Docker API. So when you run Docker on the command line, it uses the API to talk to the Docker daemon that runs on that system. The Docker daemon is what performs all the magic of managing your Docker containers. But the Docker API uses, or the Docker client uses the API. By default, that listens on a Unix socket, but it can listen on a TCP socket, which we really recommend that you use with TLS. You do not have to use it with TLS, but you really, really should. Just thinking of the date, yes, okay, so we have released Docker 1.3, which had a CVE where boot to Docker previously, so boot to Docker, by the way, is a operating system that includes Docker. So you can boot this from an ISO on bare metal or in a VM, and it will run Docker for you, and it's just basically a tiny Linux core system that has Docker in it. Well, we also have a macOS installer for that, so it installs VirtualBox, and it will map your home directory into the VM, and it installs Docker on your local macOS machine or Windows machine, and sets up the VM, etc. Well, this was enabling the TCP socket without TLS. It turns out that if you were to access a web browser on your desktop, which nobody does, somebody could create a post form which would redirect to communicate to a local Docker daemon that's running a local host and control Docker. And if you control Docker through the remote API, you effectively have root access. And with file mappings and other things, you basically also would have root access to the macOS box. So having TLS enabled on your Docker socket is really, really important. So please, please use it. Which, by the way, just to clarify, TLS is now default with boot to Docker. And if you're running a version earlier than 1.3, please upgrade. We use various community tools such as Mesos, Kubernetes, Fig, Vagrant, Ansible, all use the Docker Remote API. This is an example of how to create a container. You would just do a post containers create, and I know the text is kind of small. You provide JSON on the left-hand side that you can use to specify commands, images, volumes, etc. You do not have to specify all the options. I believe the minimum is just providing the image. Everything else will be inferred to a certain set of defaults. And then you'll get HTTP 201 created and the ID of the container. You can do anything from in the Docker API that you would do from the Docker CLI, which is listing containers, creating them, inspecting them, listing them, logs, starting, stopping, restarting, resizing, exporting, creating, attaching, unpausing, pausing, waiting, removing, copying files. I really don't want to list everything. You can do many of the same operations, basically CRUD operations and so forth for images. And there's miscellaneous things where, let's see if there's anything important. Oh, so Docker 1.3 added Docker exec. So this is a new feature for those that might be familiar with Docker already, that you can take a container that's already running and you can add a new process to it. So you can say, I want to attach a shell to this container so that I can actually operate with it, list files that are in there, interact with those processes, and so forth. Before this command, it was pretty hard. It was kind of a black box, right? So if you had a container running, it was kind of a black box, and you didn't know what was going on inside of it. Now with Docker exec, you can actually attach a shell in there and do things, right? Because we don't recommend that people run SSH in the containers, if only because it provides an unnecessary attack surface for that container. It's an additional process that you're running that it's a network service that people can get into and attack. With Docker exec, you can run a shell process in that container and do whatever you need to.
How can you block that?
How can you block Docker exec?
Yeah, because if I'm running something that's running in pod and I don't want people to be able to serve a shell and attach to it. It was good. It was hard. I understand if you're doing dev and you want a shell to it.
Well,
Great.
it was possible to do that before.
Attaching an extra process.
Yes.
Okay.
It just wasn't an exposed feature of Docker. So you could have downloaded nsexec and done that. You could have, if you didn't have the binary, you could manually execute system calls to do it.
Okay.
So all it's doing is actually integrating this into the API and into the shell utilities to make it easy to do what was already possible, just really inconvenient. So that's actually all my time. Well, actually not all my time, that's all my presentation. I have 10 more minutes for questions. I can also do some demo. Yes, back there, DC.
So in AWS or a typical infrastructure as a service like that, you would rely on the data persistence layer like RDS to store your data and just destroy your instances and recreate them. So you can use a golden image and update that golden image and just recreate your instances constantly.
Sure.
How do you do that with something like Docker? Do you create the database as a Docker instance and have some fancy way to move the data around every time you create an instance? Or?
So for storing images, there is the Docker registry. If you create a container and you make changes and you want to do a snapshot and create that as a new image, you can do that. So you can do Docker commit container, and that will create a snapshot as a new image. And then you can do Docker push to send it to the registry, which would be the same as in EC2, snapshotting your instance and creating a new AMI from that.
Right, but probably not realistic if you have 50 gig or 2 terabytes of data on a database. You would probably want to use this separate, not a database in Docker, is what I'm saying.
Right, so
So you could have your actual physical box has terabytes of storage. You just mount locations and that into your Docker.
right.
Docker then just runs your database, the software itself, and uses the local file system on the host.
Right. Yeah, so Docker volumes, Docker volume solves that, as you're saying, in actually 2 ways. So one, you can give it an anonymous volume, and anything written to that volume does not become, and you just give it a name. You can say -v database store, and that does not become part of the snapshot of that container. The other part of that is you can do the bind mounts, where you can say this directory on the host gets mapped into the container. And that also does not get part of that snapshot. And then you would use out-of-band tools for managing backups of that database.
Right.
You had a question?
It was actually in line with volumes. Most of the documentation I read is that if you, actually Docker is strongly suggesting build them out locally because it breaks down some of the modularity of your images. Like
Right.
they talk about building a volume image, like
Yes.
a volume container. I
Right.
guess that's what you would do for like database and
Sure.
for logs and this all.
Right. So there is a perspective of some people at Docker, Docker Inc., that, and within the community, that you should use data containers, which are, you run this container, and you run like some sort of empty process that owns this data, and that data will persist as long as that container exists, which does work. One of the problems is that if you remove that container, you lose, and you remove all containers that have access to that data, the data disappears. And that can be somewhat transparent and surprising to users, which is why, although it's a theoretically great model to use, in practice, it has kind of this, this big pitfall. There is some work going on at Docker within the community to make the creation and deletion and listing of volumes, these anonymous volumes that are Docker native, more explicit. But until then, at least I personally prefer doing host mounts. And that's just my personal preference, because I know I'm never going to lose data that way, because I am explicitly managing it. But there does, as you said, does become some portability issue as soon as you start accessing anything on the host, right? You're breaking down barriers of the abstraction model. Any other questions? I'm sure there's some questions. All right, you have a lot of questions.
So I'm not a Docker user, I'm an NXC user. So
Okay.
I manage my containers manually.
Sure.
Currently, there's still, when you use NXC and the namespacing, you can sort of run containers without giving them any root access. My understanding is that in Docker, you would run one application as a user, and it would never have root access. Can you run a Docker container with something like Dovecot that needs to have root access to the container? Is it going to work? Or?
Right, so actually, the problem with Docker is more of the opposite. So Docker does not currently support user namespaces. It is on the radar, but so we're using Linux namespaces and C groups and Linux capabilities to provide this containerization functionality. These are all kernel features. LXC uses the same features. We do not currently use the user namespace. So everything that happens in the container as a user happens as that user on that host, which may seem obvious, but if you use user namespaces, it will actually do UID mappings. So root in a container is actually user 1000 on the host. In Docker, PID 0 in the container is PID 0 outside of the container. Docker, by default, actually, which I don't necessarily agree with, but is done for purposes of convenience and compatibility, does everything as root by default. So when you run, do a Docker build, if you do Docker, a run command in the Docker file, that runs by default as root. If you don't specify a user for the Docker file or for the image, or at the runtime, it will run as root. You can specify users, so you can run containers as non-root users, and I highly recommend that. But you can also run those as root. I'll also add that some of those things, such as Linux capabilities, there is a default set of capabilities that are enabled for containers that is moderately permissive. You can tighten that further. So for instance, we allow netraw inside of containers. You can disable that. So you can say that I want a container that cannot issue pings, and so forth. You can say, I'm going to run a container as a non-root user, so I'm going to remove directory access control overrides for that container, because that's never should happen, because root should never be running in that container. Thus, things that only root can do should never be allowed for that container. So you can specify a cap drop command to Docker to specify these capabilities will be dropped from the default set. Anything else? Over here.
Question. Does Docker as a company provide some type of, I guess I could say, guidelines that if you want to use Docker in a PCI environment,
Right.
these are the best practices for this?
Okay. Not yet, but two parts. So we do have solutions engineers, so that if a customer came to us, a paying customer came to us and wanted something like that, we have the capabilities. It's an option, right, for our team to provide something like that custom, or say, well, we have to evaluate and say we really need to have something like that. We have been talking internally about doing a Docker security guide or security book, which is still in discussion. But
So there's some
Yeah.
churn. There's some. What you're saying is there's some churn there.
Yeah, yeah. But it's definitely on. You know, those things are on the radar. Absolutely.
Yeah.
Okay. All right. That's it. We have like 10 seconds. So actually 3 minutes, but.
All right, is that
All
some
right.
questions?
Thank you.
So thanks to Eric for coming out. That was very interesting, very enlightening, I'm sure for a lot of people besides myself. Typically what we do, and we're going to do it tonight, is head over to Triumph Brewing Company right across the parking lot here. You can walk straight across. But before we do that, I just wanted to announce we do have a speaker for next month. It's actually going to be Julian, who asked most of the questions tonight. He's a senior security engineer, something like that, at Mozilla. He is going to be speaking about SSL, TLS at our next meetup. So it should be a very technical talk. I'm excited about it. How appropriate. And, yeah, that's it. So thank you for coming out, everybody. We'll leave all this stuff right over.
Okay.